So here's a trig modelling question. It's a good old Ferris wheel. Now I'm going to skip part A and B because these hopefully you'll be able to organise by pulling out a nice clean diagram. Always best to draw out a separate diagram, right? So that's part A and B, you should be able to get that. I'm going to focus on the trickier parts. So this video will be part C and D, and then a second video will do part E. So let's go ahead and look at part C. So the wheel turns through an angle of 2 pi over 3. So it starts at A, the seat. Now you need to understand what 2 pi over 3 is. Sometimes it's easier to translate to degrees. That is 120 degrees. Okay, so pi radians is 180. So pi over 3 is 60. Can you see that? So 2 pi over 3 is 120. So now I'm going to draw a separate diagram. I'm going to draw a diagram down the bottom here because when you're looking at the actual full Ferris wheel, there's a lot of information going on. So let's go ahead and draw a separate diagram, and we will have, here is the 15 meters, right? That's the Ferris wheel arm. Now it goes round in a circle, so that's 90 degrees to here, and then it's another 30 degrees to here. So here's my triangle, and if I take that triangle out, what I'm going to do is put 30 degrees in here. Okay, now this is 15 because it's a Ferris wheel arm, and I'm going to try and find this little H here, and then I'm going to show you why that's important, because there's the ground level, and what I'm trying to do is I'm trying to find the height above the ground. Okay, so the height above the ground is going to be 15 meters plus this extra piece here, which is this piece here from the right angle triangle. Now you should be able to see that this is sine 30 equals opposite over hypotenuse. So 15 sine 30 equals to h, and you should know that sine 30 is a half. So h equals 7.5. So the answer for part C is 15 plus 7.5 equals 22.5 meters. Okay, now let's get on to part D now. I've got it here. So the height h of a CA. So we're still considering CA. Notice the Ferris wheel is rotating this way, and we seem to have a particular model here. H of t equals negative a cos of 2t plus c. So let's go ahead and unpack what this means. So the a here is going to be the amplitude. Now this 2 here tells me that the period is 2 pi divided by 2 equals to pi. So that's the period. That's one full revolution, one full wave. In fact, that would be the time that this function takes to get all the way back to a. And the c, well, y equals c is the equation of the midline, right? So we'll put that period there. So we've got all the information we might need. So let's have a little look. Well, on the diagram, this is the midline, right? This is kind of y equals 0, the height above the ground. This is the midline, and isn't that just y equals 15? Right? And can you see that actually the amplitude is also 15? So we've got h of t equals negative 15 cos of 2t plus 15. Okay? Okay, so there's the model. Now you could put that in your calculator and go ahead and analyse it, and you would find the time for a complete turn. But we already know the time for a complete turn because that would be the period of the graph, right? The period is how long it takes to do a full wave. Now we already have that answer because we know that the period is pi. So the answer for part 2 is the time taken equals pi, which is approximately then 3.14, and then we just have a look at the units and it's minutes. So it's kind of real life. 15 meters is the center point. The highest point reached would be 30 meters, 3 minutes to get full revolution. That sounds like a decent Ferris wheel.